Hello everyone. How's everybody doing? I hope you're doing fine. We have big news today. Big news. We have pictures today. We have pictures, something amazing. It's all over the news. Someone must have seen it already. And that's that for the first time ever, let's see if I can get it here. There it is. First time ever, they took a picture of a spirit. Now, how's that? Yeah, that's the big news today. They took a picture of a spirit. They think it's a Little Red Riding Hood after she was eaten by the wolf. And she's not red, she's blue. I guess it's because her clothes changed while she was in heaven. That's all I can think of. So, yeah, big news today. People in Europe, I think it was, some big observatory, lots of people involved, and they took this picture of a spirit. Okay, so that's good to know. If anybody wants to discuss about that, something, wants to say something about it, sure, why not? We'll discuss it. How how these people took a picture of that spirit. Second issue I want to mention, and that's that we have a rational physics conference, the seventh now, going on the seventh year. And that's got to be in Bora, Sweden. And some people ask me about it, where can they find information about this? Very simple. Just go to Facebook and you'll find that there is a site known as the Seventh Rational Physics Conference. You look that up in Facebook and just subscribe to that so that you can keep abreast of whatever new developments happen in there. We're going to have more specific information, times, and so on. We're still 2 months away. And so all you can do is just go to the Facebook site and just keep tabs on it. Okay, that's how simple that is. One thing I'd like to mention: lots of people put comments in the videos, and I specifically state there so that everybody knows that we do not answer in the YouTube site. We do not answer any comment, and we make no exceptions. And the main reason for that is, we're spread out thin. We have several sites where people post information and so on, and we kind of want to concentrate that in this case, we have two sites where we are willing to answer questions. One of them is the Rational Scientific Method in Facebook. It's still open as far as I know. There's some new developments there, but I'm not very familiar with what's going on there. But the first one is the Rational Scientific Method in Facebook, and the other one is the Patreon site. And there's a little bit of problem with the Patreon site because they have all these categories. This is not me who created those categories. This is Patreon. And they have people who support, people who don't, just the general public. They have, I think, like 5 different categories. And so it's not easy to find always the comments, and so I got to get a little better on that as well. So if some of you have put comments and found no answers, well, it's because they don't have a very nice system for notifying you that you have a comment. Okay, but I'm going to try to get better at that as well. Check on it more often. I think I know where to check all the comments right now, but it takes a little bit of time. What else? someone mentioned someone mentioned that my lighting could use some help. Uh, my tidiness, my presentation, sound, many things that could be better, right? And in fact, they offered to help me on this, to try to polish up the image, the sound, everything. And yeah, thank you, first of all. Thank you for offering. Nice criticism, by the way. I want you to know that people in the past not only mentioned that, but they also said that, I have a website. The name of it is youstupidrelativist.com. Okay, I've had it for several years now. And yeah, people said, your site doesn't look too good. It's not very marketable or appealing to the general public, or, there are different comments that were made about how lousy my site looks. So I'm pretty famous for having lousy stuff out there. Yeah. And I've answered those people, and these are people who wish the best for me. It's not that these are enemies or anything like that. But I had to answer that, and the answer is that you know this site specifically, it's not. You got to think of it not as the State of the Union address. It's more like maybe Franklin Roosevelt's fireside chats. It's lie down, lay back, get a beer, take it easy, and we have a little chat, one on one. As far as I'm concerned, whether there's 100, there's one, doesn't matter. I'm talking to you. And yeah, so I don't take care of all these. I'm sure that if I had a director, movie director, and the camera guys out there, I'm sure we could deliver a much better presentation. But see, I'm not in it for the money. There's no money involved here, essentially. I have some Patreon, a group, small group, Patreon supporters, and I thank them. But certainly I can't live off of that, let alone become a millionaire. So I'm not here to make a buck. I'm not here to market my theory either. I sell a book. I sell several books. One of them, the most important one, is Why God Doesn't Exist. And people ask me about it every now and then. You can find it at youstupidrelativist.com. Anyone who does a minimum of search on my name should be able to find these things. So I don't market it here. Rarely do I mention it. You want it, look it up. If you're interested, you'll find it. One of the things that, and regarding the site, why it looks lousy, and it might stay lousy for a while, like forever. There's a couple reasons for that. One of them is that, even my sons offered that said, you can use Photoshop, and I use Paint. You're using paint. We're in the 21st century. What are you using paint for? You should be using something more advanced. And in a way, I want it to look lousy. It's somewhat deliberately, okay? The site is a sarcastic site. Makes fun of mathematical physics. And it looks at all these places where the mathematical physicists have made outrageous statements, outrageous claims, especially of proofs. And the site is designed to ridicule them. It's lampooning them, roasting them. So that's on the one hand. It's a sarcastic site. It treats them as idiots, officially. Almost every page does. Treats them like lunatics. That's one issue. The other issue is that the lousy art, I defend myself by saying that, you've probably heard of Leonardo And you've probably heard of Michelangelo. You know, they were these Renaissance turtles. They did beautiful paintings, absolutely wondrous. You know, sometimes I go to the Louvre here in France, next door. Sometimes I go to the British Museum, and also to the Vatican, by the way, Sistine Chapel, and you'll see absolutely breathtaking pictures. Now, I'm not into art at all. You know, I don't like art. It's a subject that doesn't interest me almost in the least. But like once a year, I go to these places, you know, and I just marvel at the ability that these artists had in the Renaissance to make almost picture perfect portraits. It's like if they took a snapshot. That's how good these pictures are. You look them up close, and they're really good. My favorite one is Caravaggio, by the way. He made picture perfect, you know, snapshots essentially. And you know, that was good art. All that died in the early part of the 19th century when they invented photographs. You know, they had no more reason to have painters do portraits. So what happened? They went into photographs and art started to change drastically. And you ended up with people like Dali and Picasso. Well, as far as I'm concerned, and again, I'm totally ignorant on art, but I'll just give you my humble opinion. I think their art is shitty. I think it's garbage. That's what it is. And despite that it's garbage, lots of people buy them. They want to have them. Now, some people are smart. They look at them as investments. They say, "Oh, this is going to be worth $1 million or $100 million in 10 years." So it's an investment. Okay, I understand that. But there's other people who buy it because they say, "Oh, look at the art." Well, no way. And so the issue is that you know, I could have made my site look like Michelangelo and Leonardo's, you know, good paintings, or Caravaggio. And instead, you know, I made it look like Dali and Picasso, garbage. And who knows, you know, I don't think I'll become a millionaire because of that. But what I do like about it is that, you know, I stand out. I stand out because of the shitty site. Everybody does it, you know, with Photoshop and all this good stuff, and I leave it like it is. And in that sense, it's good. Maybe the word gets around. And the other issue is that, you know, people go to these sites, my site, and they look at this and they say, you know, you could improve, you could make your site a lot better, la, la, la. And that's because they're looking at the form and not at the substance. They're not reading. They get distracted by form. And similar here, you know, people come here and they say, yeah, you know, your voice could be better, your lighting could be better, so many things that could be better. And again, you got to listen to what I say. Not look at my hair, you know, I'm getting bald, over 66, so you know, it's that time of the of my life where start losing your hair and so on, you know. I don't worry about these things. I worry about what I say. That's what I like. I like physics, and that's what I do. And so if you come here because of the physics, not to look at me, not to look at my site. I mean, those are secondary. You come here to listen to a different theory, different way of looking at the world. The other issue is, you know, I'm not into marketing. I'm not here to sell anything. And part of the reason for that is that a lot of you who are out there know, I think we're the last humans on Earth. I have a couple theories out there on extinction of man, and I don't think we're going to last too long. Now, I'm a lousy astrologer, okay? Some people say I'm a lousy scientist also. Okay, lousy physicist. I'm a lousy astrologer. I make lousy predictions, okay? So I like to explain mechanisms. I like to talk about how humans are going to die, what's going to kill us, why we can't overcome these obstacles, these things coming our way. And so I don't worry about the prediction of when. When it happens, it happens. I can only tell you the mechanism. And that's what I like to discuss. People want to discuss when. And they say, well, I don't believe you. You're not here to believe me. If you're here to believe me, you got a problem. You're here to listen to a different theory, to a different focus on physics. That's what this site is about. Covered that, a little bit of that last week. So you don't have to agree. You come here to listen to something different. And so don't get distracted by form. Don't get distracted by beliefs. You know, whenever you give a dissertation, you know, we're all human. As far as I'm concerned, I'm human so far. And there's a tendency always to try to convince people in the wording whenever things come out of you. It's, I guess, human nature. But as long as you separate that and say, well, now he's talking religion. Bill is into religion right now. That's fine. As long as you recognize the difference between science and opinion, belief, then you're okay. You just got to, you know, kind of extract from that whole presentation what you think is objective. Okay? And so, you know, since I am of the opinion that we're not going to last that long, I'm not looking at the long term. I don't expect to have my name, you know, in some kind of statue in the future, recognition. No. In fact, I think it's too late. I think that mathematical physics has advanced so much in convincing the world that there's no way of pulling it back. In fact, the news with which I started, you know, the spirit, yeah, they discovered a spirit. They said they took a picture of a black hole. What are you going to say? Okay. So if that's what you want to believe, well, then you're at the wrong site. This site deals with science in a different way. And the science we deal with, I covered that last week a little bit. Maybe I can summarize that. We have, and I started last week by saying that atheism is not a part of science. Atheism is unscientific. And that already offends a lot of people because people consider themselves rational and objective and say, look, you know, I'm convinced God does not exist. Are you saying that God does exist? No. I'm saying that atheism, together with agnosticism and together with theism, all three belong in religion. All three of them. And on the other side, you have science. You have the scientists. So you have the atheists, the agnostics, the theists. To counterbalance that, you have the scientist, the rational scientist. What is a rational scientist? A person who does this site, right? Person who does physics with objects. Okay, you don't move concepts around. That's the main one. And so, you know, when atheist says that he does not believe in God, the existence of God, that's an irrational statement. We don't believe in existence. You cannot say that you believe in the existence of a bed or of a car or whatever. You don't believe in things. You believe, if anything, in theories, in explanations. So that's what we're saying here. We're saying that atheists, and I used to be one, okay, so, and I covered that last week also, but atheists introduce God as a theory together with a theist, and so they argue, they chase their tails around in circles, because one guy says, well, I don't believe God exists. Well, I do believe he exists, and I can prove it to you. And this is how I prove it to you. And the other guy said, well, and how about this other thing? And so they go around in circles, and they've been doing this for hundreds of years. And they never get anywhere. And this is very clear. God cannot be a theory. And God can be introduced by a theist and also by an atheist or an agnostic, for that matter. You know, you can say, let us assume that God exists. You make an assumption. And now this guy might say, well, let me show you how God created the universe, for example. The other guy can say the same thing. He can say, let us assume that God exists. And we concede the assumption. We say, okay, for the sake of our argument, let's concede the assumption. What? And now the guy explains, says, look, I can show you with this assumption that there's too many problems to accept that a supreme being, did this and did that. There's too many things wrong. And so he can have a theory in which he introduces God, but hopefully not as a theory. Hopefully he introduces God as an assumption. And unless you understand, how this site is different in that sense, that we have a new scientific method, there's a lot you're not going to understand about this site. You're in the wrong site. And it takes a long time, for people who have been brainwashed on all sides into thinking in a given way, and it's hard to break out of that. It's hard to break out of that. So in this site, not only do we say that atheism is unscientific, but so is mathematical physics. All of mathematical physics. All of it is unscientific. You say, how can you say that? Look at all the technology we developed, and we have computers, we have GPS, and none of that has anything to do with science. For that, you need to define what science is, and then just apply the definition, strictly. And the definition we have here is, for science, rational explanations. That's what this site is about, rational explanations. Rational, very simple, primarily. You don't move concepts around. You don't create a spirit, an ethereal concept, and say, look, it broke the wall. What do you mean a spirit broke the wall? What do you mean my conscience went right through the wall? What do you mean love went through the wall? What do you mean information was transferred? What do you mean energy went up and then came down? Those are all concepts. You cannot move a concept in rational science. You can in the religion of mathematical physics. You can't do it here. And so if you have words in your vocabulary such as time, energy, mass, field, wave, just to name a few, then you're in the wrong site. And you're going to get, shocked by a lot of stuff that is said here, and it's all got to do with taking it back to the original definition. What is science? Science is rational explanation. Rational means you don't move concepts around. You can't say the field did this, mass did that, energy transformed itself into mass, and that's all garbage. We don't care about any of that here. We don't use math. And you say, how can you say that you're not going to use math in science or in physics? And yes, we don't use math. We go back to the definition, rational explanations. Math can only describe. An equation is only a description. A description is not an explanation. Covered that some time back, too long to cover it here. A description is not an explanation. Therefore, math can only describe, and the description does not fit with explanations. Physics and, branch of science, we only explain. So we have no use for math. We have no use for numbers. We have no use for equations. And we do not measure anything. And you might say, well, does that sound right? Imagine you had Mother Nature down here, right here in front of us. Good old Mother Nature, Mama Nature. And you're going to explain something to her. Or you say, look, Mama Nature, what is the square root of pi? She's going to look at you and say, what? What are you talking about? Mother Nature never went to college. She never learned math and sophisticated stuff like that. Mother Nature's a simple little old lady. She moves things around, and she does it with her invisible mediators. Her world is a world of kindergarten. And, most people have the opposite idea. They think that, the universe out there, cosmic phenomena, all that, oh, that's so complicated. It's over my head. It's just outrageously impossible. We'll never figure it out. The human mind is too small, and we can't deal with all this information, all this knowledge of how this universe works. We'll never figure it out. But we keep insisting and try to figure out a little more every day, but we'll never figure it out. Just beyond human nature, human intelligence. It's the other way around. It's exactly 180 degrees the other way around. Mathematics and all the nonsense that you learn in mathematics, especially in mathematical physics at the university, oh, that's complicated. They have fancy words, decoherence, and you have superposition, and you have the principle of uncertainty, and everybody trembles, oh, what could that possibly know? It's over my head. Mother Nature, she does kindergarten stuff. She moves. Here's a famous trick that she does, pen, and she drops it. You drop it. Gravity. How did she do that? Now, how complicated can it be? Think for a second. Try to forget everything you ever learned. You just woke up from a bad dream, right? How complicated was that? What we have is a pen, and it's attracted, as we know, we could go into more detail, it's attracted by the earth. It falls to the center of the earth. The guy in China lets it go and also falls to the center of the earth. The guy in the equator lets go of a pen, falls towards the center of the earth. So all pens around the earth fall to the center of the earth. Unless if you are a flat earther, well, then you have a different explanation or a different experience or whatever. Pen falls to the center of the earth. There's only two objects, ultimately. There's a pen and there's the earth. Okay? A round ball. That's it. A sphere. How complicated can that be? Why would gravity be so breathtakingly outside of even imagination? It's just a pen and the earth. Now here's another, I like this trick, Magnets. Now how difficult is this? Just think for a moment, okay? Because I don't want you going out there and getting all the math books that you have in your house and try to read them in 10 seconds. Just want you to focus on what I'm telling you right now, okay? How many pieces of metal do I have? 2. There it is. Two pieces of metal. How complicated, how breathtakingly unimaginable could magnetism be? The mechanism of one piece of metal attracting another. Do you need to go to the university to understand that? If a God himself came here personally just to see you, and he explained what the mechanism is between these two pieces of metal, do you think you would understand it? Or do you think you would need to go to college and learn calculus and, linear equations, to understand the breathtaking mechanism? Someone breaks, I like that example always, someone breaks the window with a brick. But it turns out you don't see the brick. You didn't see the brick. You just see the window broke. Do you think you would understand if someone says, look, a brick went through your window? Oh, I thought I needed to take calculus and know what energy is to know how my window broke. And here we have only 2 chunks of matter, a brick and a window pane, Do you need to go to college to understand all that breathtaking phenomenon that a brick broke the window? And this is the issue. The issue is that all those people that say, oh man, this world is so complex, we'll never figure it out, those people are crazy. They don't have their feet on the ground. Mother Nature is kindergarten stuff. Once you figure it out, you can explain it to a kindergarten, a toddler. 4 or 5-year-old kid, you explain, look, this is how a magnet attracts another. This is the mechanism. Oh, he can understand it. But a mathematician won't, because he's been brainwashed with a lot of stuff, especially with a lot of counter arguments and so on, that he cannot relate to it. He cannot imagine that it's simple. Not anymore. And so this is where the problem is. The problem is that people have this idea that the universe is extremely complicated and it will never figure it out. And, how do I explain it? Well, unfortunately for the mathematicians, I'm proposing a simple, symmetric entity, a rope. Rope is symmetric, and I hope it doesn't blow your mind away. I mean, I think I have one here. Here it is. Magnet knocked it out. There's a rope. You think you need to go to college to understand what a rope is and take a lot of mathematics courses so that you can, I guess, understand what a rope is? This is the issue is that here's what I'm proposing. 2 atoms, my fists, okay, and they're bound by a rope. And with that, we're going to explain light, we're going to explain gravity, we're going to explain magnetism, electricity, and the workings of the atom. All the invisible phenomena. And we're going to include black holes, dark matter, origin of the universe, saying there was no origin. And the rope, together with the atoms, if we disentangle the whole universe, we end up with a single closed loop thread. Now, how much more simple is that? Can you get it than that? In fact, I think this is the entire universe according to me. Single closed loop thread. This tangles into ropes, into atoms, into everything that exists. But if we untangle if we could, not that it's possible, we would end up with this. Now, how's that for simplicity? And they've been looking for simple and symmetric for who knows how many centuries now. They've been talking about simple and symmetric at least for the last 100 years. Has it become simple and symmetric? Every day they invent a new particle. We've got over 200 particles identified or labeled or invented, names for them. And there's the 12 primary ones that we have in the standard model. The graviton is not there because they have a little bit of problem explaining gravity, with particles. But all the others are there, 12 of them at least. And has it become simpler? Has it become simpler when they have to invent mechanisms which obviously violate any common sense? Not common sense, because we're not just talking about, oh, we humans have a different common sense than the universe. I'm talking about idiocy. That's what they're violating. They're in the realm of idiocy. When someone tells you that one particle can be at 2 places at once, that the rabbit can be at 2 places at once, if that doesn't make you wake up, then you are hypnotized. No doubt about it. It's got to wake you up. You can't just stare at what these people are saying or hear, what these people are saying or read what they're writing and say, oh yeah, decoherence. Particle can be at 2 places at once. It can be in 2 states. The cat is both dead and alive until you open the box, then it falls into one side or the other. Two particles can be at the same place at once. The vacuum is made of particles, and sometimes they jump into the real world as virtual particles, and then they go back immediately. They just come in to make the equations come out right. I mean, what is all this nonsense? If that doesn't shock you, then you gotta slap yourself and wake up. You're sleeping. You're listening to these people and you don't realize what they're telling you. And if you say, well, you know, we don't understand the universe, it's so difficult, well, I can't help you then. You might as well, especially if you're an atheist, then you got a problem. Because on the one hand, you got all these atheists, these big name atheists that give documentaries and talk shows and so on. And on the one hand, they say, oh, I don't believe in God. how can you be so stupid to believe in God, you know, and all this stuff. And then they go out there and they believe in Big Bang. They believe that energy was zero, and zero energy is, what is it? Zero energy, we should all do the math. It's plus energy minus energy. So when you have plus energy minus energy, yeah, you have like plus a million energies minus a million energies, then you got zero energy. And that's how the universe started. I mean, if this is what you're going to accept, then you got a problem. And for sure, you shouldn't be in this site. This site's going to laugh and make you feel bad. You know, here we're going to ridicule you. And so, yeah, what can I say? If this is what you believe in, if you believe that because of authority and because all these people can't be wrong and they study and they got a PhD and look, they're on television, and if you're just going to get swayed by all of that, I can't help you. And you're in the wrong site. Here, we're going to do physics with objects. And the object is, again, little rope. Light is a torsion, very simple. If you want to verify something for yourself, there's going to be a little bit of religion here, okay? I'm going to talk about convincing you, persuading you, or you convincing yourself, if that's what you want to do. Go home and put a rope tied between two poles or whatever. Just have the rope held at the opposite ends. In fact, you can have two friends hold on to them on either end and torque it. And the way you do this, the way I do it, is, you know, I put two clothespins at the outer ends. In other words, I tie it from wall to wall, post to post, whatever, as tight as I can, pulled it tight, and put two clothespins. Move one of the clothespins. The other one, you can't even see it move. That's how fast it is. That's how fast a torsion wave is. In fact, I filmed it, and you can't, even the film can't pick it up. That's how fast it is. You would say it's instantaneous. And so, yeah, light, for all practical purposes, for everyday things, it's instantaneous. Why? Because it's a torsion on a rope. And we know for sure that, for example, transverse waves and longitudinal waves, they are much, much slower. Just look it up for your own sake. Earthquakes, they have both longitudinal and transverse waves. In fact, transverse waves, it's through transverse waves that they determined that the center of the Earth has liquid in it. You see, how did they do that? How did they know that it's liquid there, and what's that got to do with transverse waves? Well, the way they know this, the way that they know it's a solid for most of it. You know, you have a core there, and then it's floating within a liquid. Well, the way they determine these things is that they know that transverse waves cannot transfer through the liquid. And so that's how they determine the core itself is solid. Whether you believe them or not, but this is their conclusion. This is how they determine these things. And, you know, the transverse wave cannot go through fluids, but the point here is that transverse waves are slower than longitudinal waves. Longitudinal waves during earthquakes are 1.7 times faster than transverse waves in the same earthquake. In other words, the longitudinal wave reaches you faster than the transverse wave that comes behind it. So if light is a transverse wave, as everyone in the 19th century all the way to the 20th century, even some people today, 21st century, they claim that light is a transverse wave. James Maxwell, in fact, characterized it with, you know, he described it mathematically. If light is a transverse wave, it should go slower than sound, which is a longitudinal wave. And the analogy would be that when there's lightning, you would hear the thunder before seeing the lightning flash, because sound should travel faster than light if light is a transverse wave. So transverse wave is a slow mechanism. And not only is it slow, but like I'm saying, a torsion wave is faster than anything you can imagine. We haven't built a rocket that goes as fast as a torsion wave. And the only way you're going to get a torsion wave is along a rope. And of course, the rope also explains many other aspects. Gravity, no problem. Action at a distance, if we're connected by physical ropes, you know, as the object approaches, the ropes fan out. And as the object gets farther away from you, the ropes, you know, act almost as a single coaxial. That's why gravity is weak at long distances and strong at close distances. Anyways, I don't go into all the details here. All I'm saying is, with a rope model, it's very simple. It's symmetric for sure. I mean, this is symmetric, right? Right? And it's also got a symmetry in the direction of the torsion wave. When this torques, the torsion wave goes both ways. One of the criticisms I have against both transverse and longitudinal waves, or even particles, is that they can only travel one way. And one of the comments once made was that about light is that the signal arrives before it leaves. That's a description. Light is so fast that it, you know, leaves before it arrives and arrives before it leaves. It just, you know, instantaneous. It goes both ways. Light goes both ways. And the only way you can explain is, again, with a rope mechanism. You can't do it with one-way waves or one-way particles. That's the point. Okay, anyways, this is about rational science. What is rational science? We're going to do things with objects. And specifically here, we're going to do this with the rope. And the rope is simple and symmetric. And if you untangle everything in the universe, you're going to end up with a single closed loop thread. That's the entire universe. What is space? Well, space is the subject I'm going to talk about today. In fact, I've been talking about space for the last 2-3 weeks now, so you can look up what I've said so far, and I'm just going to go relatively quickly through it. How did we end up with space, or better yet, I'll call it nothing, for lack of a better word. Nothing. What is nothingness? That's the issue. And where did that come from? Well, the mathematical physicists today are of the opinion, or they claim to have proven, that nothing is something. How do they arrive at that? Well, they start out with their tension getter. They said, look, the universe came from nothing. Matter came from nothing. And not only matter, actually space too came from nothing. And you say, what do you mean it came from nothing? There was no God out there with a magic wand saying abracadabra? Yeah, they say there was no God because they're atheists. Atheists don't believe in God, right? They prove that God doesn't exist. And so what happens? They say, yeah, there was no God. So how did it come into existence? Well, again, you have this positive and negative energy. You put them together, you get zero energy. And that was the starting point. We started the universe with zero energy, and fortunately we have a mechanism, a self-propelled mechanism, where zero energy turns into positive and negative energy. One's going to be the mass, the other one's going to be the gravity, and here we are, 13.8 billion years later. Matter. We have energy converted into matter through E equals mc squared. So that's the general theory, the overall theory. And so in order to find out, what they're talking about, we have to look at this word energy. I mean, is there such a thing as energy? What these people are saying essentially is that there's an ether out there. They haven't invented anything new. The ether comes, like I explained in a couple videos ago, comes all the way from the Greeks. And nothing has, absolutely nothing has changed. All these people believe in the ether as a bunch of particles. Gazillions. Quadrillions. Countless particles. And the issue was whether each little particle has a space as a background, or the particles themselves are space. That was one of the issues the Greeks debated. And also, the other issue that I brought up, whether it was infinite. Because whether you're talking about nothing, assuming space is nothing, whatever nothing means to you, is nothing infinite? Or is there a point where nothing stops and something else, thought continues, the fifth dimension or whatever? God, he's out there. And if it's particles, do the particles end somewhere and what continues? So the word infinity has been around for a long time. People are trying to say, well, is the universe infinite? And when you look out there in the night sky and say, yeah, it's infinite, I can't see beyond a certain range. And so you say, yeah, it's infinite. But all you're saying is that you can't see beyond a certain point. That's all you're saying. So the question, conceptually, is the universe infinite? Is the space made of particles? Is the ether and space the same thing? Or is ether something that's contained within space? Like if space were some kind of container of sorts. Those are the issues. We go back to the Greeks and we find out that they had the same questions. We haven't resolved anything. Today they don't like to use the word ether, but they say, yeah, the space, they call it empty space. They say empty space, they have to put the word empty, and then they tell you, well, it's not empty anyways. Because empty space is made of fields, it's made of energy, it's made of virtual particles. It's got all this activity and junk in there. And so the question is valid. So we go to the Greeks. The Greeks take us back to, essentially to the 16th century, because not much happened between the time of the Greeks and the 16th century. During all that time, people essentially incorporated the ether, Plato's ether, not Aristotle's ether. Aristotle's ether was out there beyond the moon. He said it's out there, it's not here, it's for the gods. But Plato said, it's down here as well. And essentially people took Plato's view and said, yeah, the ether is here, it's my soul. But they did like the part about it coming from the stars. And so the stars were where the good and bad souls came from. And they got into your body. When it was bad, you got sick. And when it was good, well, then you were a nice person, you went to heaven, or who knows. And that's lasted for 1,600 years, essentially, or a little more, right? All the way to the 16th century. 16th century, things started to change. We started having people like Descartes, René Descartes, French guy, mathematician really. And he started talking a little more about the ether in, you could say, scientific terms. Let's concede that. He started trying to make sense of the ether. And among the reasons he tried to make sense of it, he says, look, the ether is really like where the light goes through, or the ether itself is light. But he identified the ether, or related it to light. And I guess a lot of people at the beginning of that century, the 17th century, thought in the same way, probably all the way up to the 1650s until mid-century. Then things started to happen. By that time, both Galileo and Descartes had died. And now you start having a new generation of mathematical physicists. You got Newton, you got Christian Huygens, you got Leibniz in Germany. Robert Hooke was not really a mathematician, but he did a lot of research with his microscope. You got people coming into, you can say, heavyweights, at least mathematically speaking. They started to throw mathematics at the problem. And they had a problem with identifying what it was, but they started describing it mathematically. And for that, they were qualified. And they reached different conclusions. Now, one of the things that people have is that they think that Newton and Huygens debated between the particle and the wave. One said, no, light is particles. The other guy said, no, the light is waves. That's not the case. Both Newton, this is essentially the picture that they had, or have today, that Huygens talked about waves and Newton talked about particles. And that's really not the case. The case is totally different. Both of them talked about particles. Here's Huygens. Let me show you proof, evidence, more than opinion, I guess. Here's Huygens, Christian Huygens. This is from his book, 1690, the Treatise on Light. And he says, like in the second paragraph there, underlined, particles of the ether. The issue with Christian Huygens, he treated the particles of the ether as fluid matter. He did talk about spherical waves, so that wasn't invented in the 21st century either. That's been around for a while. He talked about the particles of the ether, and he saw it as fluid matter. Okay, so that's Huygens. What did Newton have? Here we put Newton. Newton, in his treatise on optics, he criticized, that waves would not be able to travel straight. He had a problem with waves traveling straight. He also had problems with perpendicular motion. He already had a sense that transverse waves, could not really move up and down through the ether. So he had a problem with the balls of ether, the little particles moving up and down as something went through them. He had a problem with that. That's where the difference was between Huygens and Newton. And to some degree, Newton was right. Like if we go to real quick to the 19th century, just to show you what the problem was, we have here Mr. George Stokes. Okay, and Stokes, he was a wave guy. And Stokes, by that time, by the time he writes this in 1845, the transverse wave was already solid, in the minds of everybody since Freneau proposed it in 1821. So here we have, 24 years of transverse waves already where everybody essentially believed in them. But look what Stokes says. And Stokes is the guy who's going to sit the most on the Lucasian chair, which is what Newton, he used to sit on that chair. And Stokes replaced him, sat for 54 years on that chair. So he's the guy who's been the most on the Lucasian chair in Cambridge. But this is what he says. He says, the more particular explanation of the cause of aberration usually given does not apply to the theory of undulations, unless we make the rather startling hypothesis that the luminiferous ether passes freely through the sides of the telescope and through the earth itself. The undulatory theory of light, however, explains so simply and so beautifully the most complicated phenomena that we are naturally led to regard aberration as a phenomenon unexplained by it, but not incompatible with it. So what's the issue with Stokes? He was a very influential guy in his days. Stokes is saying that, we can't explain light like from a physical perspective. We can't explain light with undulations, with the transverse wave. but it's so convenient. So convenient, you know, it looks like all the descriptions that we have point to a transverse wave, but he was aware of Newton's argument that, you know, these things, you know, a transverse wave, at least by that time, they were pretty certain of it. Transverse wave cannot propagate through a fluid. And if the ether was made of all these moving particles, right, then how could the transverse wave go through it? So this was the issue. The issue was that, you know, how does a transverse wave move? So where does it start? Well, again, you know, the debate between Huygens and Newton lasted all the way to the beginning of the 19th century. You have first Thomas Young. See if I can get him from here, see if I can find him. Here it is. We had Thomas Young, and he resuscitates essentially the slit experiment. And what Thomas Young does, he explains it in terms of waves, and he says, you know, Newton was really wrong. And a few years later, Augustin Freneau, he's the French mathematician, he goes in there and explains it also in terms of waves. But his real radical proposal comes in 1821. A few years later, after, like 5 years later, after he explained the slit experiment, Freneau goes in there and explains polarization. And he explains it in terms of transverse waves. For the first time, he introduces the transverse wave. And I'm not sure if he was aware, because there's really no clear-cut thing that I could find, but whether transverse waves could go through a fluid. But if he was aware of it, he ignored it altogether. And he says, look, I can explain the polarization with transverse waves. And how do you explain it? And I want to show you something so that you can see the contrast between what he proposes and what the rope model proposes. His picket fence scenario, or his picket fence explanation theory. He says, look, imagine there's light going in there, and there you have that cross. The cross is supposed to be the electric and magnetic fields. He was not aware of electric magnetic fields, but he was aware, or he had a sense that light was some kind of transverse wave. So he said, look, the picket fence, which is the polarizing material, typically Iceland spar. And, you know, if the atoms are oriented, or the molecules are oriented vertically, that will block the horizontal component of light. And only the vertical component of light goes through the slit, okay? And then what happens, you know, when that second piece of light, the vertical portion, hits the horizontal polarizer, it gets extinguished altogether. So that was his theory. He says, look, light goes in, the first polarizer isolates the the horizontal component, and the horizontal polarizer extinguishes the beam altogether. Now, look at the difference with the rope model, just for the sake here of argument. The picket fence goes through the holes, through the interstices between atoms. Or between molecules. The rope model is exactly the opposite. The rope goes to the atom relays the signal along another rope to the next atom behind it. And when you turn that second atom, really a molecule because it's part of that polarizer, when you turn it at 90 degrees, well, then you have what I explained in Buenos Aires of how polarization is done. And that's too lengthy to explain today. But I just want you to show you that there's a difference between Fresnel's proposal that light goes through the holes, through the interstices in the crystal structure of the calcspar, versus the rope model, which goes atom to atom or molecule to molecule. Okay. Okay, with that, I'm going to adjourn today, and I'm going to continue with 19th century transverse waves, hopefully on Sunday. We'll see you then. Bye-bye.